from this point forward, we're going to change gears a bit. Up until now, we've been talking about basic features in Java, right? Classes, variables, loops, kind of all these built-in features that are common to Java and that you've probably already seen in other languages like Python. At this point in the course, we're going to shift to larger data structures that you can actually build in your program, right? So these are things that we're going to build in Java, but you could build these same things, these data structures, in a language like C++ or C or whatever else you want to use. I've used right now the term data structure. So data structure, right, is say something like an array, right? Something that's used to store information. However, something like an array is very simple. Basically, we can add information whenever we want and take out information whenever we want. What we're going to start introducing here is this new this new way to store information called the stack, right? Which is going to give us different rules that govern how we can access or change the information inside of it. So the first thing we're going to do is we're going to talk about collections. Actually, before I get any further, quick mention, I'm going to be using the slides for this section of the textbook. Normally I like just doing coding videos because I think it's more helpful for you guys, but there's not really any programming in this section, but yet I kind of want to give some of my explanation. So rather than just sit in front of a blank screen or me try to sketch in Paint, I'm going to be using the slides here. And maybe in a couple of the other sections I'll do the same thing, depending on kind of what our needs are. So the first thing we're going to really talk about is the idea of a collection. And if you think back to the looping chapter, you'll remember something called an iterator. And way back then, we also mentioned the term collection. The idea is this. I have some class that represents a container, right? There's a bunch of stuff inside of it. All right, it's not just, say a class that models a person or a bank account or something. It's a class that models a whole bunch of things that are put together. One example, and people may debate this, of a collection is an array, right? An array is this one object, right? This one thing that stores all this information inside of it. Collection is just a general term we use to talk about a container. And all collections are going to contain some methods or some operations that let you manipulate the information inside of it, right? Access stuff, remove stuff, add stuff, whatever it has. And there are actually a bunch of different collections, right? Not just array. The first one we're going to be implementing is stack, right? That's what this whole chapter is on. But there are lots of different ways to store pieces of information. Later on, we'll also cover queues. If you take kind of the next class in the sequence, which is SIR 222, algorithms and data structures, you also see things like maps, sets, trees, right? Other ways to store information. For now, we're just going to focus on stacks and queues in this class. In general, collections are divided into two categories. One is linear, the other is nonlinear. Let me actually jump right ahead to this next slide because these pictures will make a lot more sense. Over on the left, we have an example of a linear collection. The idea of a linear collection is that I have some things I can visit in order, right? I start at the top and I work my way down, right? One after another. It's some linear order, right? You can imagine maybe you have an array. If you're in an array, you can imagine looping over it, starting at the 0th position, and then just walking for it, right? Visiting one element at a time, or maybe if you're skipping some elements. The point is you have this linear ordering, right? You're starting at one side and walking down to the other. The other type of collection that exists is a nonlinear collection. So this is something that I would call a tree. Maybe you guys have seen this in something like a discrete mathematics course. But the idea is that things are simply not so simple, right? Instead of every element, right, everything in our collection, right, everything that I'm storing in there, instead of one thing following another thing, I have kind of a choice, right? So if I look at this element here, right, if I'm here, I don't have just one thing that follows me. I have two things, right? So here it's just branching every time, right? I have different choices, right? There's not this kind of linear sequence that I can start somewhere and just walk and go, see this one, then this one, then this one, then this one, right? That's what we had over here. Instead, I have kind of this spread out thing, right? Where I have to make choices. I may have to go left, I may have to go right, or whatever else you have. That's what we call a nonlinear collection. In general, I would say it's when you have a collection and it's not really clear how it's ordered, right? Do I look at the left first or the right first? When it's not clear what order I would look at them in, right, or what order I print them out in, then it's nonlinear. And of course, you might think to yourself, oh, well, if I have something that's nonlinear like this on the right-hand side, maybe I can just define a rule, right? A rule that would tell me how I could visit all these things in a sequence, right, in a linear order. And that's something you could do too. And that's actually one of the topics in the more advanced course that comes after this one. So these are the basic ideas of linear and nonlinear collections. For this course, we're just going to be talking about linear collections. So at this point, we're going to start talking a little bit more about abstraction. And on the next slide, we're also going to introduce something called abstract data types, which is really what we're going to be focusing on for the rest of this class. So let's think back to the section a while ago, I think it was chapter 5, about encapsulation. So he talked about this idea that a class should take all the stuff it has and try to hide it from the outside world, right? We shouldn't have, more methods available or more variables available than what the outside world needs in order to leverage the functionality inside that class. So that we call encapsulation. Well, kind of the dual of this is the idea of abstraction, right? Classes should form abstractions for whatever they implement, right? That's the goal. That's the other reason to hide kind of your extra methods, your other variables, right? There should be an abstraction. We want to hide details that aren't relevant to the classes outside, right? To the other parts of your program that use it. In general, all classes end up forming abstractions, right? Again, we've already discussed this idea that we want to have well-encapsulated things. And that process of well-encapsulating everything is forming an abstraction, right? Hiding things that don't matter. So what we're going to be looking at in the rest of this text is something called abstract data types. We've already talked about data types. That's something pretty familiar to you, right? That's something like an integer, a double, a string, right? What is the type of information that you're storing into something like a variable? Well, the new thing that we're going to look at is this here, abstract data type. Also, we just use letters ADT. ADT is kind of the general term we use for a new data type, right? Something that we've built. So whenever you do something like make a new class, you're actually defining a new ADT. You're defining a new abstract data type, right? All of a sudden you can make variables who have a type that matches the class you've just built, right? You've added something to your programming language almost. The third term here is data structure. So data structure is referring to the actual concrete implementation of a class, right? When we just say something like ADT, we're actually referring to the interface, right, or the API that a class provides, right? What is the overall thing? Not how is it actually implemented concretely, but kind of what does the outside world see? Versus the term data structure is talking about how that thing works inside, right? How is it set up? Is it using an array? Is it using two arrays? Is it using something called a list that we'll see later, right? There are a bunch of different ways you could implement that class. A bunch of different data structures you could be using behind the scenes to provide that functionality that your ADT is supposed to represent. Your ADT may be something like a bank account that maybe it has a array of transactions, right? Or maybe it just has a reference to another object that has that information about previous transactions. We don't really know from the outside how your abstract data type works, right? We don't really know how that data is structured. The last remark here in the slides is actually pretty valid. A lot of times people kind of blur these terms, right? ADT, data structure collection. A lot of times you'll have people kind of referring to ADTs and data structures as being the same thing, but really they're not. Really, ADT is referring to the interface, right, the API, versus data structures talking about the concrete implementations. Unfortunately, people kind of just get sloppy sometimes. They mix those terms. Collection people are pretty good about using, right? Again, collection is just a class or an object that contains a bunch of other things, right, and provides some methods to manipulate them. This next slide is built on the things we talked about in that encapsulation section. So again, we have the idea, right, that I have some class that may use a collection, right, this thing over here, some class that uses a collection, and then I also have a class that implements the collection. And in between I have an interface. And there's a couple things going on here, right? So the first thing is that this class over here, this class that implements the collection, right? So maybe it's something like a stack or a queue or a list. These collections we're going to be spending some time on. This thing here, right, is hopefully well encapsulated, right? It's all kind of self-contained. It doesn't let people manipulate parts of it that they shouldn't. And then we have, right, our class that uses that collection, but between them, right, is this wall here, right, this interface. The interface is essentially a list of behaviors or operations that the collection has, right? So the collection can, support adding something or removing something. Maybe it has a bunch of other things inside there. All of those things are listed out in an interface. An interface essentially is just a list of methods and the kind of the types that are associated with them and the parameters that they have, right? So maybe we have an interface, and that class outside that wants to use the collection is just going to use that interface. It's not going to directly interact with the class that actually implements the collection. Instead, it's only going to interact with that interface. And then the class that actually implements that collection, that class is going to provide all the functionality kind of behind the scenes, right, for that interface, right? So behind the scenes, right, it's going to provide all these different methods here. Over here, right, our class is using these things from the interface. It's not using them from this actual implementation, right? It talks to the interface, and the interface then is going to essentially guide that information to the actual implementation, right? So this class over here is simply something that provides all the functionality required by an interface, right? It provides all these different methods and maybe some other methods. But the class that uses the collection isn't able to see that extra stuff or even see that concrete class. All this class knows about is the interface, right? Kind of the agreed upon contract, if you would, of the functionality that needs to be available for this particular collection, right? Some people are going to use that functionality. Other people are going to implement that functionality. Point is, it's all embedded just in an interface, right? An agreed upon contract of what there needs to be. Let's take a moment to talk about the Java API. So Java has an entire collections API, or sometimes they just call it the Java Collections Framework. The point is that there's a whole bunch of ways to represent or structure your data, right? A whole bunch of ADTs, a whole bunch of data structures, and these things have been around for a while. So Java has actually already implemented all of those so you can use them in your program. The general process we're going to follow for the next couple of sections is we'll first introduce a new data structure, a new abstract data type in terms of the Java API, right? So we'll do a simple demonstration that uses the Java pre-existing implementation to solve a problem. And then once we have kind of that practice from applying the collection, right, applying the API, then we'll actually look at how we can implement it ourselves. Remember that even though all the collections are already provided for us, it's still a very valuable experience to go through the process of implementing those collections ourselves. We want to use that as a learning experience so that when the Java API has maybe a collection that doesn't actually suit us, right, we need to customize it, we know what to do, right? We know how to build things that are more appropriate for the particular problem that we're interested in solving.